surface mass density. The following items were used in the preparation of this educational resource: a standard ream of paper, a digital scale, and a scientific calculator. What is surface mass density? It is a physical quantity defined as the total mass m lying beneath a flat surface, divided by the surface area A of that surface. This quantity is commonly represented by the Greek letter sigma and expressed mathematically in the formula shown below. In the International System of Units, sigma is measured in kilograms per square meter, although alternative units such as grams per square centimeter are also frequently used. By definition, sigma is a relative measure. For a given solid object, for example, its value depends on the specific area of the object being considered. Interestingly, the surface mass density of an object that has macroscopic dimensions does not depend on the shape or size of the area we choose, as long as the depth h of the uniformly distributed mass remains the same everywhere beneath that surface. This happens because the mass hidden under any area A is directly proportional to that area. For example, if the area doubles, the amount of hidden mass also doubles. If the area is reduced to half, the hidden mass is also reduced to half. Triangular, circular, or square regions all follow the same rule. The amount of mass beneath them scales with their size. As a result, when we calculate the ratio mass/area, this scaling cancels out, and the value of the surface mass density remains constant. As an example, let's calculate the surface mass density in grams per square meter of a standard 8.5 inches by 11 inches sheet of paper. First, let's measure the mass of one sheet of paper. With the mass and the dimensions of the sheet, we can determine its surface mass density using the procedure that follows. In the calculation, the color blue is used to emphasize the conversion factor applied. This conversion factor is used to convert the area of the sheet to square meters. This is the approximate surface mass density of the sheet of paper. The calculated value of 74 grams per square meter for the sheet's surface mass density is very close to the one reported on the ream of paper used in this video. Moreover, since the sheets in the ream are nearly identical, the surface mass density of any macroscopic piece of paper from the ream should be very similar to this reported value. Where does the 20 pounds reported on the ream of paper come from? According to Copilot, this number corresponds to the weight of 500 larger sheets of paper, each having a surface mass density of 75 grams per square meter and dimensions of 17 inches by 22 inches. It is relatively easy to verify that claim mathematically. We just need to determine the weight, mg, of one such sheet, and then multiply the result by 500 to obtain the total weight, w, of the 500 sheets. Details follow. This conversion factor is used to convert grams to kilograms. This conversion factor is used to convert the area of a sheet to square meters. It is easy to verify that this expression has units of kilogram meter per square second. Remember that 1 kilogram meter per square second is equal to 1 Newton in the International System of Units. This conversion factor is used to convert newtons to pounds. After rounding, we obtain the number reported on the ream of paper. Thanks for watching.